Barry DeCicco has been a statistician in the automotive and healthcare industries, and a lot of his work has been in kind of customer and patient and employee satisfaction. And I think he just started today as he works for the Center for Statistical Training and Consulting at Michigan State University. And Barry was just mentioning how dead it was on campus today because today was his first day. And thanks, Barry, for giving this talk on introduction to text processing. Really appreciate it.
Thank you. So one of the things I've got is the review text here, a rating, a recommend score, and three organizational categories: class name, department, division name. And that's what I'm going to use for my raw data. Okay, so I'm going to do this again. Okay, so I'm going to run through the presentation first and then show you things from the Jupyter Notebook. I did my work in a Jupyter Notebook because that's what I was most comfortable with. So what I'm going to do is two things, which is sentiment scoring with a Python module called text blob, predicting categories using some machine learning and NLTK and scikit-learn. NLTK is the natural language toolkit, and it's sort of the starting point for Python when you want to do language processing. It's got a lot of features. You can look up the documentation and just read for many, many hours. I want to give you a shout out to medium.com, especially their section towards data science. Very reasonable subscription, and almost everything I've done with text analytics I learned from there. So it's very, very good. And I have full references to everything in the end of the presentation. And in my Jupyter notebooks, whenever I look something up in the cell, I'll put a comment with the URL to that thing, so I can remember what I did, so you can look up what I was doing. Okay. So sentiment scoring, we're just trying to assign a positive or negative score to each piece of text with the idea that we can, it's basically a variable about a piece of data. We can track it, we can associate it with demographic variables such as department or customer demographic. You can use a lot of things for this, but I use text blob. And text blob is another Python package, which again does a lot of stuff. You can go into its documentation, and it basically has many, many features. And the way you work on it is to take a piece of text and convert it to something called a text blob. And then the text blob has attributes and methods in Python. By the way, usually the trickiest thing in this I've seen is what's called tokenization. We'll cover that later. So basically, again, install, import. So I'm going to run it on some text. So here's the text. Note that's misspelled. Then I lowercase it, convert it to a text blob, correct it, find the sentiment, the polarity, and the subjectivity. So it's basically saying, what's the sentiment score and how strong does it like that, believe that sentiment score. So you can see what happens as I go through this. We start with the original comment, lowercase it, do some spelling correction. So I convert it to a text blob, then do some spelling correction on it. Then compute the sentiment. So it's got a polarity of 0.7 and a subjectivity of 0.9. It believes that polarity quite well. At this point now, we can basically look at what our polarity is. We can also cut it by various things. The reason I had done this one first, this is not really good. I'd done actually the ratings by whether or not there was a comment. The reason I did that was if I saw a big difference in the rating for comment versus no comment, our sentiment score should be judged only for people who make comments. And if only a few people made comments, we're dealing with a very non-representative piece of data.
What does polarity mean?
Basically, these are positive comments.
Okay.
So what we're seeing is generally people are have a positive comment about what they're doing. There's an old saying in customer satisfaction that the people who you frequently have the people who are most happy or least happy, most angry will leave comments. In this case, we've got a 1 to -1 normed scale. And what we're seeing basically is people are leaving comments because they like things. What you can also do then is go in and say, let's look at the polarity less than 0 and see what's different about that. Yeah, go ahead.
Is that taken from that one line of text you put in, or is that taken from the whole data set?
The whole data set. And that's something I should have put in there. This is an example of processing a comment.
Okay.
So in a sense, what I did was I took like if this, in fact, this is one of the comments that people left. So we're going to go through the whole the whole data set later. So then I would do things like this. I would look at the polarity versus the rating. If you're familiar with this, this is a mean and confidence interval chart. What you see here is, for example, for people who rated it 3, their polarity was about 0.16 with a very narrow confidence band because there's a very large sample size. This is about 2,300 comments. So this can be somewhat misleading. The only thing it really tells you is that rating and polarity are positively correlated. Now here's a box and whisker plot. So what we're seeing here is the center half. By the way, are you seeing my cursor move or not?
No.
Okay, I'm sorry. I'm pointing to everything. The center box shows the center half of the data.
I guess
The
I'm still
whisker-
seeing the histogram.
I don't see a whisker plot.
Yeah, we still see the polarity histogram.
Okay, so you see there?
Yes.
Okay, so something interesting is going on. So the box and whisker plot, that center box for each rating, shows the center half of the polarity scores. You can see where there's a whisker going up and down from the box. Can you?
Yes.
Okay, that covers a certain range, which if it was normal data should cover about 99% of the data. So what we know is we have a bunch of outliers here, and with a vast sample size, we expect that. But we can see, the middle of the data is pretty much going up as the rating goes up. What we also realize is, if you notice, if you looked at rating 1 and slid sideways to rating 2, you notice those boxes overlap. What it's telling us is that if we took a median rating for a median sentiment for a polarity for rating 1, that could also be a rating 2 and maybe even a 3. So we don't have detailed discriminatory power. We cannot really use the rating to predict the sentiment to predict the rating. And that's what frequently happens. Okay. So, but the thing is, what you can do now is compare sentiments, look for changes in sentiments. You can treat this like another variable in your data set. The trick is it's not an extremely high predictive power variable. You can use it as one more variable in machine learning. For example, you could take the high sentiment scores and the low sentiment score, high polarity and low polarity, and look for keywords which appear differently to get an idea of what people are praising and what people are complaining about. So now I'm just going to go through how we sort of process data because I wanted to do some machine learning on this. The big thing with text is you've got, if you've dealt with white space anywhere, there's this big question about what a word is or what a chunk is. In text processing, you have what's called tokenization. One of the problems is, for example, if you looked at my 23,000 comments, they're generally text strings, they're generally different from each other. If you want to use this in a machine learning model or anything else, it's not really usable by itself. What you want to do is break each comment into pieces, in a sense, into words. And what you're hoping for is that there'll be keywords which have nice predictive and discriminatory power. And the term for this in natural language processing is tokenization. Break text into sentences, break text sentences in the word, standardize the words. And that means, for example, if we go back to this one comment here, what we might find is that we see the word absolutely, we see the word wonderful, we see silky, sexy, comfortable. So if you want to think of it that way, is we could create a matrix where we break each comment into a set of words. So think of, and I should have had a picture of this. Pretend now that we have 23,000 comments, and we have 10,000 comment columns. Each column represents a term that we found in the data set. For example, in this comment, and for this comment, if you went sideways when you hit the absolutely column, you'd see a 1. You'd see 0 for everything else. When you see the column marked wonderful, you would see a 1. And same for silky, sexy, and comfortable. The idea is this set of columns now should have fewer unique values. Many will have no predictive value, but you're looking for the ones that are. For example, for intimates, you might find that silky and sexy are very strong, have words with very strong predictive power. But you don't see that for, say, outerwear.
Hey,
And again, I should have put a picture of this up because it took me a while to figure out what's going on. Python will talk about various matrices, where basically you can think of the data set as having, say, an outcome, and then however many words you have in your data set, it'll have that many columns minus what it thinks of the low value words. And then you can use those as predictors. You have a lot of predictors. Probably most of them don't matter. Some of them will. You get 100 or 200, put them into a machine learning model and see what you've got, both for predictive purposes and for getting an idea of what predicts an outcome, such as people repurchasing, purchasing, or being happy. So could you hit the next slide, please? I feel like we're back in the 90s. We have to say next slide. Someone hits the thing in the back of the room. Okay. Now, there's a lot of ways of doing it, and it's always tricky because you're trying to get a computer to parse a human language. And usually the things you want to do is once you've broken it usually by white space and punctuation into words, you want to stem it. You want to trim the words to a root in various ways. One of those is a simple trimming. For example, writing goes to rid. The other is lemmatization, where you're trying to find like the grammatical root word of the term used. So you'd want to convert writing, road, etc., into the stem word, the root grammatical word ride. Spelling correction is not perfect. And one of the things I found out is if you've got a lot of misspellings, it bogs down your program quite a bit. In the Jupyter Notebook I'm using, it processes data at 0.04 seconds per comment. In Volkswagen Credit, somebody, as far as I can tell, for one comment, just mashed on the keyboard for a few thousand characters, and it stopped the program because it kept trying to correct it. It kept trying to find the way where it should be split up into words and then correct the word spelling and find the root words, and it just couldn't do anything. You basically said, find me the gold in this garbage, and there was no gold. So next slide, please.
Hey, Barry. Quick
Yeah.
question.
Right.
So there's lots of different things you can do here. Like even there's lots of different types of stemmers, porter, snowball, and all that stuff.
Yeah.
Did you have some sort of evaluation metric, or how did you decide how to like tune all these like essentially hyperparameters as you were working?
This is not well tuned. This is my first run through the thing, and a lot of it is really to give you an idea of what sort of things you can do. So you can use this as a start for your experimentation.
All right.
Yeah. Yeah, one of the things I told Dan, if there's any real NLP people here, they'll get up and leave and discuss. But that's a good question. When you look up tokenizations, there's a lot. And if you look, and at the end of this presentation, there's a selection of article series in Medium. So it's worth experimenting with. And this gives you an idea of how the steps go, where basically what the steps I run it through here, where we start with a comment, which has the slashes to indicate, which has slashes for escape characters due to import problems. I had to manually set up the second bullet point where we basically sub those out lowercased it, use the NLTK tokenization, remove the stop words, lemmatize the words, join them back together into a line. And the reason I did that now was because we had, in a sense, I recreated the comment as a set of tokens, which could be broken apart and used again. So if you hit the next slide. Okay, and this is what it did. So you notice this is not pretty. What we're really looking for here, you know, for example, the so pretty, it wasn't corrected. So basically, in some cases, it just doesn't find the correct value. What we're really looking for here is that there are tokens in here which have good predictive power. For example, you might find out that when everyone uses the word so with multiple O's, then that's an intensifier. It's a predictor of high or bad results. So would you do the next one? Okay. And then this is what's going on in Python now. Basically, it's looking at your tokens and it's creating a set of predictors. It's now taking the tokens in each comment and expanding them like a list into one column per token in your comment. And it compiles a dictionary. Then it assigns a number to each token. For example, you may find that so, S-O-O-O, is number 5473 in your dictionary. So at this point, you have quantitative predictors. You can also use the count of how many times they occurred as well. And there are two common ways to do this, which is to make a vector of those counts and what's called a TF-IDF vectorization, which is called a term frequency, inverse document frequency weight. If you go to the next slide, please. Okay, the idea of term frequency, inverse document frequency is that words which occur a lot within a comment, which don't generally occur, have high value. Words that occur in like every single comment have low value. For example, if you did not remove stop words, so things like the, and, I, etc., are in there, what this method should do is de-weight them quite a bit. Whereas, for example, comfortable should be upweighted, sexy and silky should be strongly upweighted, because this set of reviews covers a lot of clothing of which you do not say that. For example, if you're trying to predict intimates, sexy and comfortable would be up, sexy and silky would be strong predictors. Okay. And again, in some cases, with the way you'll just see this described when you look it up is, for example, let's say you had a corpus consisting of a bunch of emails. Then words which are used a lot in an email don't count. They're downweighted. For example, if you see from and to, those shouldn't count. Those should be counted almost nothing. Something that applies a lot, like billing department. If you saw the word billing, that should be weighted a lot, unless everybody in your group is complaining about billing. I don't think I'm giving away trade secrets when I say that when you're looking at customer satisfaction with money, billing is a big, very important word. So please go to the next slide. Okay, and I've pretty much covered these. So go to, so in a sense, the last thing is if you didn't process your stop words, this method should deal with it. It just may take longer to process everything. So go down again. So what it comes down to is I divide the data into 2/3 training and 1/3 test data. There are 15,160 rows in the training data. When it vectorized, there's now 10,846 columns. It means it basically found that there was a total set of 10,846 unique tokens, many of which will not be good predictors in your machine learning model, some of which should be, and you're looking for those few that are. Next slide, please. Okay, so at this point, you can feed the vectorized data into any machine learning method. You can explore the resulting models and look for feature importance to find out the important tokens. This is where you could also, as someone pointed out, play with different forms of tokenization to see what, if things make, if some methods cause some terms to pop and or give you a stronger predictive model. And the next. Okay, so basically at this point you can play cluster analysis and some text grouping methods. So the next one. Okay, now I think the thing is going through the Jupyter notebook would probably take about half an hour.
Barry, can I ask?
Yes, certainly.
Did you? It seems like NLTK does everything you needed to do. Why do you need text, Bob? Also?
No, you would not.
Okay, but that's just a different tool if you wanted to
Right.
work with the text, but not
Yeah.
through the data science stuff.
Yeah.
Okay.
In a sense, in fact, when you look at my Jupyter notebook, you'll see a lot of columns which indicate the history of what I did. Like at one point, you'll see some bold saying I pulled this in from another version for something else. And the way the notebook will work is it'll do the usual thing, which is set up the packages, import the data, examine the data, do some spelling substitutions, pull in the stop words, go through the sentiment scoring, and then go through a loop where it goes through these set of tokenization processing, and then feed those into machine learning models.
Okay. Thank you. Thank you.
You're welcome. And if we go down a little, anyone else with some more questions?
Actually, can I hit one more on that?
So you can hit several.
Thank you.
I mean, you're paying by the question, so I accept that's no problem.
No, this ties to something I've been thinking about for a long time because I do recruiting, and I get a lot of effectively fraudulent resumes, and I've been thinking about writing routines to pre-identify what represents a fraudulent resume.
Right.
And I was going to tag each resume file with things like the list of words that's in the resume itself. Is there any reason to use text blob, or can I do all that with NLTK? Can I get
you can do everything with that with NLTK.
Okay, good. Yeah.
Because what your goal is that in a sense, think of it this way. If you're manually tagging words,
right.
So if you took a spreadsheet and you said resume 1 and you just went through an Excel side by side, typing in the different words, and then you went to the next one and you put in like a 1 for each one that had the same word, and you extended the columns to the side to deal with the new words that you found in that resume. And then did that for your whole set of resumes.
Right.
You'd end up with, say, a row with a false valid flag, and then say 733 columns, each of which corresponds to a word. So that's what's being done here, except it's being done for you rather than you have to hire someone to do this.
Okay. Yeah, no, I also, some of the stuff I want to do is playing with like the raw data, like does this particular sentence appear on multiple resumes?
Yeah.
Or was it clearly copied from somewhere else?
Okay. I don't know how to do that. I've never tried that. And one of the tricks is there's something called an n-gram, because this is sort of looking for individual words. What you could also do is extend it. Look for the term n-gram with an N, like bigram, trigram.
Okay.
And that's where you start looking at pairs of words.
Very good.
And then triplets of words and so on. I don't know how to do what you're going to look for is a plagiarism lookup or plagiarism spotting. I don't know how to do that.
Chapter 5 in mining massive data sets by Ullman et al. Has a bunch of stuff about near document duplicate searches and stuff like that. And it talks a lot about like character engrams and stuff.
Sorry, so that's mining massive data sets?
Yeah.
And how can you spell the author?
It's like Ullman, I think. He wrote the compiler book too. The Dragon book.
Thank you for that. I had some ideas, but this sparked some overflow.
Yeah.
I have that compiler book.
Okay. By the way, Ullman might be Ullmann, But in Amazon will probably help you really quickly.
It's got a dragon on the cover, right?
The compiler book, yeah.
Yeah.
Mining massive data sets has this like PlayStation 1 looking 3D graphic of like a prospector with a huge gold nugget.
Okay.
Okay. Thank you, guys.
So, yeah. And by the way, you could probably play with if you didn't have NLTK, you could probably play with like Python dictionaries and run a dictionary through each data set, each file, and compile one huge dictionary with some sort of matching to which document they appeared in.
Yeah, that kind of hit on something like that, or really creating a hash of each row and then comparing those hashes across documents.
Yeah, because for example, one of the things you can do in the tokenization is one of the first steps is split into sentences.
Right.
So at that point, you could look for duplicate sentences.
Cool.
Or, and again, what you could do is just run it with the words and see what sort of interesting things you get from a simple model.
I'm sorry, I didn't mean to take this over. I appreciate the help.
Don't worry, it's a good question. It's good application. In fact, that would be a good topic for a talk later in the year. No, I mean, you could say, okay, I used the simple token model, and so we did. Then I'd use a bigram model. Then I tried to break it into sentences and things like that.
This is my next project. Right now, I'm working on a big database thing. But
yeah. Okay, so could you hit the next slide, Dan?
How long did it take to run that, by the way?
Oh, that's a very important comment. I'm running it on my computer, and for the 23,000 comments, it took 1,400 seconds. Yesterday, I experimented with running on Google Colab, which I'd been wanting to get around to. It ran 6 times as fast. It ran 300 seconds. The problem was I found out there's a couple packages which I could not get on Colab. They weren't that important, but like there's a pattern package for doing some text substitution, and that could not be installed on Google Colab. But in general, I think probably installing it on Colab would be the way to go because it was a 6-to-1 speed. I also recommend when you look at my notebook, it's going to have a timer like every 1,000 records. It prints out the record number, and that was because it was taking. I started off on a few comments, then like 550 and 500, and somewhere around 500 it was locking up because I encountered some really bad comments, garbage comments. So you still run into that problem. So the next slide should have NLTK. Sentiment score. Okay, here's the stuff in Medium. So we have some people playing with opinion mining and sentiment analysis. Sort of two articles that look at it from different viewpoints, the same idea. If we go down another, we're going to get basically this is where a guy did a systematic step-by-step looking at all this stuff. Tokenization, parts of speeches, lemmatization, stemming, stop words, and sense tokenization. In a sense, this is where a guy did the work that I should have done, where they go through different methods and see how they work. And the advantage is you can grab the code from him, and you'll get an idea of how different approaches would be coded. And the next page. Again, here's some more links. Basically, how to use this in scikit-learn, the TF-IDF thing, and scikit-learn site where part of the scikit-learn site where they go and working with text data. And next slide. And that is it.